worksheet, calculations, graph, and then the lab notebook too. The lab notebook is not considered to be part of the lab report, but you need to turn in lab notebook each time with the lab report. Yeah. All right. So first thing first. Island. We all know island, right? Everyone. Yeah. So go to your island, and you see everything there. So first of all would be the lab schedule. So let's take a look at the lab schedule. So where are we? What are we? Yeah, we always lost. Every day, every morning, I have to think very hard. Today is what day? Monday or what? So today we are here, yeah. Now, so would be Wednesday, experiment 2 and quiz 1. Well, when is your lab report due? That will be on the 26th, Wednesday, because I promised all the bad things fall on Wednesday. And hopefully I will use the weekend to do the grading and return back to you on Monday. So your lab report is going to be due on Wednesday 26th. That is, when you walk in, you better have your lab report ready. Don't say, I need this, I need that. If you, after the first 5 minutes or so, will be considered late. Okay? So if you are late on that day, and that will be also late. Okay, let's be professional. That's the lab schedule. Okay, what do you need? What do we want? Well, it's in the syllabus. Alright, so get the island, you have the course syllabus. Alright, so you take a look at that. So which is here. So experiment 1 will be 60 points. How do you earn and get your 60 points? So would be fill in the blank of the worksheet and then make a graph and show all calculations. No abstract writing. Notebook duplicate. Now notebook is not belong to the 60 points. Notebook is not belong to the 60 points, but you need to turn in your notebook. Well, let's take a look at here. Because notebook is belong to your performance point. While lab report would be that 60 points, so they are in separate account. Well, so much and so much, but what should you need to do? What are we looking for? It's right here, under the red. You need to do all this. So read and follow all here. Should have all these items or elements in your lab notebook. Again, no red ink. Oh my God. Well, one more red up in the syllabus, believe or not, it's right here too. Okay, so take a look at all this. And then do all those. Then you will get your 10 points if I pick this one to grade. I may not grade all lab notes each time. I may not do that. But if I do, then will be as much as 10 points. And then we have a little study guide too, you know, for your quiz, knowledge check, or things like that. So we have that in here. So anyway, let's talk about the lab report now. So we say fill in the blank of the worksheet. Well, where is the worksheet? Well, blank worksheet. Everybody see that? Yeah, okay. So you go to that, and then you pop up or pop out the worksheet. I purposely make it in Word document. I know Rose, you know, my colleague, she just so she used a PDF. That's fine too. I want to do PDF, but I thought I'd be nice and easy for you guys is in Word document. So this is your file. You're going to fill in the blank. Now, before I go on, perhaps I've been joking, but not joking. So because we have another up here section, say notes of for experiment 1 to experiment 6. So they what we mean by notes? What do you mean by notes? Really is the answers, I hate to say. So tell you what to do or give you some answers or guideline what to do in here. So you may want to pop up the notes file as well. So at this point in time, I'm not very good in the computer. Perhaps I would have 2 computers when I do the lab report if I were you. Why? Because one computer I pop up the notes, one computer I pop up with the blank. So I can swing my head back and forth. You got me? Alright, so seriously, especially the first one, I told everything. I just want to get everybody on board. Yes?
Do we have to print it out with it like filled in, or can we fill it in?
Alright, so when you turn in the worksheet, you can do one of the 2 things. One, you can print, hit the print as blank, and then handwritten. That's okay. Of course, I hope the handwriting is okay to read. Second, you type in here, and then you hit print. That's why I like it to be a Word document. If I do it in PDF, you must print and handwritten. Yeah? So either way is okay. Now, because I'm nice, and then I make it in a Word file, and then you type in here, and then bum bum bum, and by the time I know when we pop up the Word document, depends on what computer, what software you use, and so on, it may look different. That's headache 1. Headache 2, when you type in something, it will move, you know. So things will move, and if things move, I ask you to fix it when you turn in, or before you print it. We know what we're talking. So don't hit print until it gets fixed. Now let me say one and have it in the record. So when I say fill in the blank, I meant fill in the blank, including each box, including if we have multiple pages. Each page, I want you to fill in the blank. If you don't, something missing, I will take points off. I know you don't like it, and I don't like it, because I say, how come my student cannot follow instruction? Fill in the blank. You don't fill in the blank, I don't like it. Okay? I know you will come, oh, how come you take 2 points off? Because I didn't write this or that? I say, yeah. Okay? All right, enough. So, here's the first column, reaction number and trial numbers. How many reactions we have?
6.
How many reactions we have? One more time. How many reactions we had for this experiment? Look at this table. Sounds like what? Looks like 3, yes or no? Yeah, only 3. You got me? So you have reaction 1, you have reaction 2, you have reaction 3. But each reaction you may do many times. So you may do first trial, and then you may do a second trial, and you may do a third trial, and so on and so on. Yeah, you can do the first reaction with many trials. Yeah, but at the end of the day, how many reactions we have? Only 3. You got me? Now, of course, if you swing your head, I hate to say, I did it in here. So reaction 1, 2, and 3. So sounds like because reaction 1 we do at 4 different temperatures. So altogether we did as many as 8 trials. Yeah? Yes or no? How many temperature we did with reaction 1? How many different temperatures? 3 with the water bath, but did we do it in the room temperature? So altogether how many? 4. But if you do each temperature twice, so altogether sounds like 8. You got me? So we get that straight. Okay, now what about the concentration of iodine, I minus? What's the concentration? What's the concentration? So the concentration, if you look at the table 1 on page 52, so the concentration of Ki is 0.20. Everybody see that? Yeah? So it's 0.20? Yes or no? Well, it was 0.20 when we provide you, but what happened in your reaction? So you took how much? 2 ml, yes? You took 2 ml out of that. But by the time you combine 2 test tubes, test tube 1 and 4 for your reaction 1, so you combine this 2 test tube, how much how much was it? How much? When we have test tube 1 and 4 together, all together, what is the total volume? 12, you see? So you are no longer 2 mil, but it's 2 divided by 12. That is your dilution factor. Everybody got that? Yeah. So don't say 0.2 parenthesis 2 over 12 to me. Don't do this back to me, please. Why? Because I want you to pull out your little calculator and punch and then get the number. I know in the notes I give you this. It's just telling you how and where they come from. But don't mean you're going to do this back to me. So you need to get your calculator and punch and see what that number is. What is that number? Huh? So that is 0.033. Yeah? How many sig fig? 2 sig fig. Alright, let's move on fast. Oh, what about the peroxide disulfate? What is the peroxide disulfate? So if you look down in the bottom, so it was 0.1. So it was 0.1. So, but it was 2 mil divided by 12. Yeah. Again, don't give this number to me. It would be punch your calculator. That will be equal to what? 0.017. Yeah. And what about the disulfate? So that was 0.005, but then we did it in 2 mil, I believe, divided by 12. So that was 8.33 to the power of minus 3 or something. Let me take a look at the notes. 4. Okay. Yeah. So I wouldn't mind just one more sig fig in here, so that you, I know should be 2. It just a little bit more would be more info, so that we see it's better. Now, so what about the temperature? So if your trial one was done in the room temp, so your room temp was what, 20 degrees C? So 273 plus 20. So that would be 293, yeah? What's your time? What's your time? Someone donate your data. The first trial you had. Somebody?
154 seconds.
154, 154. Okay? So this will be what? Second. Don't give me minute. Do not give me minute. So you can take a look at, of course this was, somebody's data and so on. Now, I know a semester after semester, no matter how I say, people say, oh, they're all same. Let me copy and paste all in here. And copy and paste. They're all same. I say, oh my God. Should they all be the same? Yes or no? No, they are different. Remember I said we have how many reactions? 3. So they must be, 1 and 2 must be different. 2 and 3 must be different. Remember I say if we would use recipe, 3 different recipe, how come you have the same thing? I don't get it. Yeah? So do not copy and paste and making all same. So you have to humbly, really, and look at each reaction and get all your concentration in here. Are we good? All right. Now, how we get the rate constant? How we get the rate constant? So good, we have this equation, so we follow, right? So for example, using this one, all right, so the data. Do we know the change of peroxydisulfate? Do we know this guy? That is what? Equal to half of disulfate, you see? So disulfate is what? 8.33 times 10 to minus 4. Yes? Do we know the time? What's the time? 990 in this example. Do we know the K? No. Do we know the initial concentration of the peroxydisulfate? Yes. That was on 0.167. Now the reaction order, we should have do the reaction order first, really, but we do the opposite. So we knew the answer is 1, so we will use 1 in here. And then what about the iodine? So 0.033, same thing is 1. So now we can solve for K. So really the K is equal to half of 8.33 times 10 to minus 4 divided by 990 and then divide by 10. So that will be your K. So that will be your K in here. Yeah? And then we have the unit too. Are we good? Now, then you go to the next one and so on. So all together you have perhaps as many as 12. Yeah. But really you have how many K? What do we say? K is what? Temperature dependent. So how many temperatures we need for this reaction? 4. So we have 4 K. Now how you do the reaction order? I never really go over this. I ask you to follow the example we had on page 50. So you compare between reaction 1 and 2, and then 2 and 3. Of course, when you compare reaction 1 and 2, you must use the same temperature, the room temperature. Yeah. Are we good? Now, don't worry. So we need to make a graph, but we talk about that in 1 minute. Again, how many ray constant we would have? 4. Why 4? Because we had 4 different temperatures. So you have that. And the temperature would be in Kelvin. Now, be sure you have the units, all right? So I did the unit for most, but not this one, all right? I just want to tell you. Are we good? Now, because it's the very first one we do for lab report, so if you look under the notes, I have a picture of experiment 1 from the previous student, so which is here, all right? So this is almost perfect, you know. So you, again, if I were you, I would have a computer pop up this picture. By no means copy. I don't mean to ask you to copy. Don't copy, all right? But be sure, look at if you want to, and be sure how you can get all this. Why are they? What are they? All right. So this student did a good job. So reaction 1, 2, and 3. Only 3 reactions. No reaction 4, 5, 6. But we did reaction 1 8 times. That's okay. That's okay. You can do 1,000 times. That's okay. And then we did reaction 1 with 4 different temperatures. 1, 2, 3, 4. 4 different temperatures. Got me? So now you look at the K in here. That's 1K. If you take the average, pretty good. That's your second K, your third K, and then the 4th. So this is pretty close to one another. Of course, you need to do what? The average. Okay, so yes, so I did say average, okay. So 4K, and then you're going to lateral lock the K, you got this number, and then 1 over temperature, just the Kelvin, so you got this number, yeah, so the Kelvin here, so 1 over that. Are we good? So this really would be the model for you guys. So take a look at that and compare between yours. Now, so let's go back to here. So I've done that 3 in a blank, and make sure you show calculations. Yeah. Now, one last thing is the graph. All right. So the graph, we use Excel, and so going back to the worksheet, so I say we have 4 ray constant, so you lateral lock that, so that will be your y-axis, and then we have 4 temperatures, so 1 over the Kelvin, so we have 4 inverse temperature, and of course that's we want to do the EA, that is the corrosion theory. Let's see if we have that in the equation. I might have. Okay, yeah, so that was equation 11 on page 51. So that's for the corrosion theory. So the EA and temperature. Alright, so we can have find the EA by knowing measure the rate constant with different temperature. So that's the equation we use for the graph. And I tell you how to get the EA. So the EA is -1 times the slope of the graph times the R is your gas constant, which is 8.314. Of course, you have to give me unit, and the Arrhenius constant would be E to the y-intercept of this graph. How you do the graph? So we use Excel. I know now we have the Google Sheet something, which I don't know how to use that one, but we use the Excel. I think if you don't have Excel, you have Google. I hope they are very similar, but some may be a little different with the mechanics. So for the Excel, the first column would be the x-axis, the second column would be y-axis. So we say the x-axis is 1 over temperature, inverse temperature. So all this may not be real numbers, all right? So I just make up some numbers in here. And then your lateral log, K rate constant. All this is not real, your data, but as an example. Okay? So what you need to do is highlight, and then you go to insert. What do you want to insert? You want to insert a chart. So you go see many things in under the chart. But which one we want to, we say the scatter. Under the scatter, you have 5 choices. Pick the one without anything. Pick this one. Do not pick others. Pick the one without anything. So only data point, you pick that one. Oops. So you use this one, yeah. Now, many things we need to do. Of course, the chart title. What's the title? What would be the title for this graph? Can someone tell me? Anyone? Suggestion? What's the title for this graph? Well, I told you to read page 54, right? So on page 54, number 8, on number 8, we say generate an Arrhenius plot. Yeah? So this plot must be what? Arrhenius plot. But if you just say Arrhenius plot, that's not good enough. You have to say Arrhenius plot for iodine clock reaction. You got me? So now Arrhenius plot is a very general. Specifically would be iodine clock reaction. Okay? So that would be your chart title. And then make sure you label X and Y axis accordingly with unit. Now, how you get the line pop out? So you point it to all data point, and then you right click Now, of course, this is for the PC, not for Apple. Then you right click, then you say you add trend line, and then you say linear, and then you have the line. Yeah? So we want to have the line now, but how? One more time, you click and highlight all data point, and then right click if you're PC, IBM, but if you're Apple, which I think is double click or something, I don't know. Then you right click and you say add trend line. Okay? And you have it. Now, almost done, but then we need to do the Linux function also. So you need to highlight a 2x3 first, and then you're going to type. So you're going to highlight 2x3, and then you're going to type this. Of course, in this example, it's B3 to B6, but for you, maybe up there. So you have to do include all this data, and then you type that, and then you press Ctrl Shift Enter at the same time. So I have all this telling you how to do the Linux in the appendix. All right. So at this point in time, I don't go over the detail yet. I probably will wait until experiment 4. Although I should tell you now, so I see how you guys can come up. It's in the appendix. All right. So you follow that and see what you can come up. All right. It's on page 169. All right. So the appendix. Once you have the 6th number, make sure you label and identify each and all of the 6 number. What are they? Who are they? You must include. And then you're going to print and turn in, print this, and then print the graph, so and turn in for the lab report. Are we good? So that's what you need to do because of the syllabus. So you need the graph. Okay. Anything?